carbonate has a negative charge. So what you have to do, you have to take those 2 electrons off of the total amount that can be shared. So 10 minus 2 equals 8, divided by 2 equals 4. Alright? Alright, so now we have 4 bonds that we can share. Alright, so to draw this, you know that carbon is always going to be in the middle. So you have C. And then it can either be double bonded to one, so it can be double bonded to either of the 3. Okay, yeah. So 1, or like this, or this. Voila! Because you can see by the thing, you need 4 bonds total, but it doesn't matter where you put them, where you put the double bond, because this all means the same thing, right? You put them all in the negative 2. Alright? Does that make sense to everyone? Does everyone get it? If you have any questions, please tell me. Alright, so these exceptions. So he already talked about how hydrogen, beryllium, and boron are stable with 2, 4, and 6 electrons respectively. So you just don't have to these are just FYIs, they're not going to be tested over this next Tuesday or whatever. And then, so these 2, I can talk today. These 2 compounds cannot be drawn because they're just weird and they don't have the correct amount of electrons around them to have a correct setting or whatever. Not setting, drawing. Next. So there are some that are stable with more electrons around it. So this one, you can see that there's 6 fluorine or fluoride bonded to the sulfur. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that is because it's just more stable with it, because you can have the 6 bonded to the sulfur. And this one is the 5 chlorine bonded to the plus. Yeah. Right. These are just random exceptions. Alright, so the last thing is the coordinate covalent bonds, which states, so if you have an H3 and you add a hydrogen ion, then the nitrogen is going to donate both of its electrons to the hydrogen so it can bond. So this is just another way to draw it. So you see the bonds between the NH3, and then both of these extra electrons are going to that extra hydrogen there. Alright? That just happens in some rare cases like this, when you are adding an extra hydrogen. Question?
Does that mean the other hydrogen has 3 of them, or does that electron go somewhere else? The one that the nitrogen gives both of its electrons to.